Good morning all. Welcome to physics class. Today I am going to speak on the chapter Thermodynamics, in that expression for efficiency of diesel engine. So in order to derive the expression for efficiency of diesel engine, as indicated in the PV diagram or from the indicator diagram, B to C, pressure remains constant. So that is, from B to C the pressure remains constant. Now let us consider 1 gram of the working substance. Then the quantity of heat absorbed is given by Q1 equals 1 into Cp into T3 minus T2. Call that equation 1, where Cp represents specific heat of a substance at constant pressure. Now from D to A the volume remains constant. That is, from D to A the volume remains constant. Then the quantity of heat rejected will be Q2 equals 1 into Cv into T4 minus T1. Call that equation 2, where Cv represents specific heat of a substance as constant volume. So now dividing equation 2 by 1, we get Q2 by Q1 equals Cv into T4 minus T1 divided by Cp into T3 minus T2. Call that equation 3. So then we have Q2 by Q1 equals 1 over gamma. So we know that gamma is equal to Cp divided by Cv. So therefore we get Q2 by Q1 equals 1 over gamma into T4 minus T1 divided by T3 minus T2. From the definition we have efficiency eta equals 1 minus Q2 divided by Q1. Substituting for Q2 and Q1, we get eta equals 1 minus 1 over gamma into T4 minus T1 divided by T3 minus T2. Call that equation 4. Now from PV diagram, so the points A and B are on the same adiabatic. So therefore we can write T1 V1 to the power of gamma minus 1 equals T2 V2 to the power of gamma minus 1. Call that equation 5. So rearranging these terms, we get T1 equals T2 into V2 by V1 whole to the power of gamma minus 1 equals T2. Taking V1 denominator, we get T2 into 1 divided by V2 by V1 whole to the power of gamma minus 1. Or T1 equals T2 into 1 over rho whole to the power of gamma minus 1. Call that equation 6, where rho equals V2 by V1 and it is called the adiabatic compression ratio. Similarly, the points B and C are at the same pressure. So therefore we have T3 by V3 equals T2 divided by V2. Call that equation 7. Or T3 equals V3 into T2 by V2, or T3 equals T2 into V3 divided by V2, or T3 equals T2 into E. Call that equation 8, where E equals V3 divided by V2 is called the combustion expansion ratio. Then the points C and D on the indicator diagram are on the same adiabatic. So therefore we can write T4 V1 to the power of gamma minus 1 equals T3 V3 to the power of gamma minus 1. Call that equation 9. So now rearranging and simplifying the terms and writing the expression for T4, we get T4 is equal to T2 into E to the power of gamma minus 1 into 1 over rho whole to the power of gamma minus 1. Or finally T4 equals T2 into E power of gamma into 1 over rho whole to the power of gamma minus 1. Call that equation 10. Substituting the expression for T1, T3 and T4 in the efficiency equation, so we get eta equals 1 minus T1 by gamma, T4 minus T1 divided by T3 minus T2. So now substitute for T1, T2, T3 and T4. So and simplifying the expression, so finally we get eta equals 1 minus 1 over gamma into 1 over rho whole to the power of gamma minus 1 into e to the power of gamma minus 1 divided by E minus 1. So this is the expression for efficiency. Thank you.